Today we're working on 3.4, solving rational equations. A rational expression is a polynomial divided by another polynomial. So that's what we'll be seeing in these equations today. Let's write down a couple examples. So part A, they give me 1/2 plus 3 over x equals 4. Well, we've kind of done something like this before, because when we were solving linear equations, I had fractions and I told you a trick to get rid of the fractions. Well, that's what you want to do in this section. You want to get rid of the fractions. You want to get rid of your denominators. So when you look at a problem, you want to look for the LCD. In this one, well, to cancel out 2, we would multiply by 2. To cancel out x, we would multiply by x. So the LCD in this one is 2x. So we're going to multiply the whole equation by 2x. And when you're first starting out on these types of problems, it's best to write out all your work. So that means you're multiplying 2x times each of the terms. And we did that to cancel out the denominators. So you should see that the denominators cancel out. In this first one, we've got a 2 on top and a 2 on bottom, so those 2's cancel. We're left with 1 times x, which is x. In the second term, we've got an x on top and x on bottom, so those cancel. We're left with 2 times 3, which is 6. And over here, we didn't have a denominator, so we can just multiply those together. We get 8x. And in our problems, we're going to be left with either a linear equation or a quadratic equation, because those are the equations we've learned so far. So they're going to give you problems that either end up in a linear or quadratic equation. So just solve them how we learned. This one's linear, so we're going to get x by itself. So I'm first going to get x on the same side. And divide by 7. Okay, and I shouldn't have circled it so quickly because we had variables in the denominator in our problem to begin with. We need to just check to make sure that our answer doesn't make any of our denominators 0. Because remember, you can't have 0 in the denominator. That makes it undefined. Okay, notice this is the only place where we see x in the problem. If we plug 6/7 in for x, it's not going to make it 0 in the denominator, so we know we can keep our answer. Of course, you can check your answer completely if you want to. It's not necessary, but you definitely have to check to make sure it doesn't make your denominator 0. Let's try a couple more. So part B, I've got 3 over x minus 2 plus 2 over x plus 1 equals 1. This one's a little bit different than our first one. Notice in our denominators, we've got a whole expression. We've got either a minus sign or a plus sign. That keeps this expression all together. In order to cancel that out, you're going to have to multiply by x minus 2. To cancel this one out, you're going to need to multiply by x plus 1. Okay, so that's what I'm going to multiply the whole equation by, x minus 2 and x plus 1. So I'm going to multiply each of the terms by x minus 2, x plus 1. I will show an example where I don't write out this step, because when you get comfortable enough, you don't need to write out this step. But I definitely recommend when you're first starting these problems to write this step out so that you can easily see what you're canceling and what's left over. Okay, so I've got 3 times x plus 1. Go ahead and just distribute that. So we've got 3x plus 3. Okay, and this one, the x plus 1's cancel. And I've got 2 times x minus 2. So again, I'll distribute that. 2x minus 4. And in the last one, nothing cancels, but let's go ahead and start multiplying that. So we're just foiling. We've got x times x, x squared, x times 1, negative 2 times x, and negative 2 times 1. This one, we see that we're left with a quadratic equation. In order to solve, well, our main ways of solving quadratic equations, our first step is to set the equation equal to 0. I'm going to put some like terms together first, but that's my ultimate goal, to get one side equal to 0. So I've got 5x minus 1 equals x squared minus x minus 2. And I like to keep my x squared term positive, so I'm going to move these two terms over to this side. So I'll subtract 5x, add 1. So we've got 0 equals x squared minus 6x minus 1. Okay, so making sure that you saw that. This is where I stopped. And then when I did that to both sides, I got this. Okay. All right, well, I like to see if I can factor it first. So there is just a 1 in front, so that means my middle term is my sum, my last term is my product. Can I multiply two numbers and get negative 1, but then when I add them, I get negative 6? I can't think of any, so I'm going to have to put it in the quadratic formula. Okay, so just a reminder, there's our quadratic formula for us. I'm going to plug everything in. So b is negative 6. So negative 6 is a positive 6. And then I've got negative 6 squared minus 4 times the a was 1 and the c was negative 1. All over 2 times a was 1. Simplify it. I've got 6 plus or minus square root of 36 plus 4 all over 2. Okay, 6 plus or minus square root of 40 all over 2. And I can do some simplifying. So let's take the prime factorization of 40. 2 goes into that 20 times, 2 goes into that 10 times, and 2 goes into that 5 times. Okay, so we've got a pair of 2's, so we can take a 2 out, and there's a 2 and a 5 left over, so that's 10 when you multiply them back together. And finally, we can take a 2 out of all of these terms. So we get 3 plus or minus square root of 10. Okay, I won't circle it yet because I'm supposed to go back and look at my original problem and make sure that the answers don't make my denominator 0. Well, what's going to make the denominator 0 here? If I plug a 2 in, well, my answer was definitely not 2, so we're good to go there. What will make it 0 here? -1. Well, one of my answers wasn't -1, so my answers are good. Just check to make sure it doesn't make your denominator 0. Okay, see, I've got 1 over x minus 2 minus 2 over x minus 3 equals -1 over x squared minus 5x plus 6. Okay, well this one is starting to look a little messy. We've got this x squared minus 5x plus 6 in the denominator here. To cancel it out, you're thinking, oh, I'm going to need to multiply the whole thing by x squared minus 5x plus 6. But we can make it simpler than that. Before you decide what your LCD is, if there's anything that can be factored, factor it out. It's going to make what you need to multiply by a lot easier. So I'm going to go ahead and factor this here. Again, there's just a 1 in front, so my sum is -5. My product is 6. What two numbers do I multiply and get 6? When I add them, I get -5. Well, -2 and -3. And look, that's what we had as our denominators for our other two expressions. Okay, well that's great news because I can multiply by x minus 2 and I'm going to cancel out this one and it'll cancel out this one. And I can multiply the whole thing by x minus 3 and it'll cancel out this one and it'll cancel out this one. So I'm going to show that, multiplying the whole thing by x minus 2, x minus 3. And I'm going to show this one more time where I'm multiplying each term by x minus 2, x minus 3. Make sure the whole problem's in the screen for us. Okay, so in the first one, if I take the time to write this all out, I can easily see what's canceling and what's left over. Okay, so I highly recommend until you're really comfortable doing that. And then 1 times x minus 3 is just x minus 3. Okay, in the second part, I've got the x minus 3's canceling. Okay, don't lose this negative. Maybe I could have even kept that negative over here to make it look a little bit easier. Okay, so it's a -2 that we're distributing through. Okay, so I've got -2x plus 4. And then both of them cancel over here. And I'm left with a -1. Okay, well this one's a linear equation, so we'll get x by itself. I'll combine like terms. I'll subtract 1. And I'll divide by -1. Okay, again, don't circle your answer right away. Check to see, does it make any of our denominators 0? Yeah, if I plug 2 in for x right here, it makes the denominator 0. If it makes any of your denominator 0, you have to just cross it out. It doesn't work because it makes the problem undefined. If you plug in and you've got 1 over 0 here, the problem's undefined. It doesn't work. We don't have an answer. Since it was the only answer we got, this one we just have to write for the answer no solution. Okay, but you might have a problem where you get more than one answer and only one of them makes the denominator 0. Well, then the other ones that were left are your answer. Part D, I've got 1 over x minus 3 plus 1 over x plus 3 equals 2x over x squared minus 9. Again, factor any of the expressions that you can. This one is a difference of 2 squares, so we can factor that one. We get x plus 3, x minus 3. Oh, and again, that's what these two denominators were, so that's great. We know we just need to multiply the whole thing by x plus 3, x minus 3. Okay, and this one I'm going to go ahead and not show that long step. Show that once you get comfortable, you don't need to write it. You just have to be careful and remember what's canceling out. Okay, so you're taking this whole thing and you're multiplying it times the first term. So the x minus 3's cancel, and we're left with 1 times x plus 3, which is x plus 3. Again, it's this whole thing being multiplied times the second expression. So the x plus 3's cancel out, and we've got 1 times x minus 3. So that's just x minus 3. And this whole thing times our last expression, both of them cancel out this time. So we're just left with the 2x. Okay, we'll get the like terms together. So I've got 2x, oh, the 3's cancel, equals 2x. Oh, what did we write for the answer when we had the exact same thing on both sides of the equation? We wrote infinitely many solutions. Okay, well, we have to be a little bit careful in this section, right? Because we do have denominators where we have a variable in the denominator. We can't plug anything in for x that'll make that denominator 0. So what makes the denominator 0 here? If we plug a 3 in, and if we plug a negative 3 in. So the answer to this one's all real numbers except 3 and negative 3. Or if you want to write it in interval notation, we'd write negative infinity to negative 3, union, negative 3 to 3, union, 3 to infinity. Okay, notice I put parentheses with the negative 3 and the 3 because they're not included. They are not included in the answer because they make the denominator 0. Okay, so you're welcome to write all real numbers except for negative 3 and 3, or you can write it out in interval notation. Your choice. Okay, I have one more that I want to show you, and I can fit it over here. Part E, I've got 3 over x plus 1 equals 2 over x minus 4. You can do this one just like we've been doing the other ones. We see the denominators are x plus 1 and x minus 4. Multiply the whole thing by those two expressions, and you can do exactly like what we've been doing. But this one's a little bit different. We can make it a little easier. We've got just one fraction on this side and one fraction on this side. We can cross multiply. Okay, so when we cross multiply, we're doing exactly that. We're taking 3 times x minus 4 equals 2 times x plus 1. okay? You can only do this when you have one rational expression on either side, on both sides of the equal sign, okay? If you have more than one rational expression on one side of the equal sign, you don't want to cross multiply, okay? But cross multiplying makes it a little faster, so we'll go ahead and distribute. 3x minus 12 equals 2x plus 2. And we've got a linear equation, so let's get the x's on the same side. Subtract 2x. Add 12. And we're finished. 14 doesn't make either of the denominators 0, so we can keep it. We'll finish 3.4 in the next video.